In this video, we will review the methods of solving systems of linear equations. Solving a system means taking two or more equations and finding the common solution. We will review graphing by hand, graphing on a graphing calculator, the substitution method, and linear combination, also known as the elimination method. Let's start by reviewing graphing by hand. Now, this method will be easy when both equations already have y by itself. Y equals this, y equals that. And what you do is you graph both equations and find the point of intersection. So when I look at the equation y equals negative 2x plus 4, 4 is the y-intercept, so I'm going to start there. 1, 2, 3, 4. I'll put a dot. The slope is negative 2. That's like having negative 2 over 1. That tells me to go down 2, right 1. So starting from my y-intercept, if I go down 2, right 1, down 2, right 1, repeat, 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 then I can see the line taking shape. I can even put another point going to the left if I go left 1, up 2. All right, so just go ahead and draw this line. Okay. All right, so we've graphed the first line. Now let's graph the second line. Y equals x minus 2. That negative 2 means the y-intercept. And the x has an invisible 1 in front of it. So the slope is 1 over 1. That means up 1, right 1. So from my intercept, I'm going to go up 1, right 1. And I could put more points by going down 1, left 1. So my second equation looks like this. So the solution is going to be the point of intersection. And we can see the two lines intersect right here at the point 1, 0, no, the point 2, 0. So this is the solution. All right, now let's try the graphing method, but this time we're going to solve using a graphing calculator. This method is also easiest when y is by itself. For this particular problem, y is not by itself, but you know what? We're going to do it anyway. I'll fill in the rest of the steps as we go. But step 1 is to get y by itself for both equations. So if I take the first equation, and I'll just recopy it here, I'd like to get y by itself, so I would subtract 5x from both sides. That's going to give me negative 4x is equal to negative 2y. To get this by itself, I'm going to divide both sides by negative 2. So these cancel out. So now I have positive 2x equals y. Okay, so this is my first equation, now with y by itself. Looking at the other equation, y minus x equals 0. All I have to do is add x to both sides, and I'm done. So y equals x. So now I have both equations with y by itself. So let's go ahead and use our graphing calculator. So next we hit the y equals button and type these equations in. So we have y equals 2x, so I'll type that in. Okay, and then we have y equals x. So now we should be able to just hit the graph button. Okay, and now we're looking for the point of intersection. In this particular case, it's pretty easy to see that it's going to be 0, 0, but sometimes it won't be so obvious. So what you do next is you do second trace, and choose the intersection function. So second trace, and you can just type the number 5, and it starts this business. First curve, just I recommend just moving the cursor close to the point of intersection and hit enter. Second curve, just hit enter. Guess, just hit enter. And then it gives you the intersection 0, 0. Okay, so for this problem, the final answer to the system is 0, 0. Okay, so I need to add a few steps onto my list of what to do. So we typed in the equations. We hit graph, the graph button. And then we did second trace. And then we chose option 5 for intersection. Okay, and then basically we just hit enter 3 times. All right, and that's it. Now let's talk about the substitution method. The substitution method is the easiest when at least one of the variables has a coefficient of 1. In other words, when at least one variable has no number sitting in front of it. So this would be a good problem to do with substitution. Step 1, write both equations side by side. So I've got x plus y. Let me zoom in. So I've got x plus y equals 25. And then I've got 3x minus 4y is equal to 12. So that's step 1. Write the equation side by side. Step 2, isolate a variable. So obviously I'm going to pick one of the variables that does not have a number in front of it. So I could either pick the x or the y. It doesn't really matter. I'm going to go ahead and get y by itself. You know what? I'm going to get x by itself just to show that it doesn't have to be y all the time. So I could subtract y from both sides. So that's going to give me x equals 25 minus y, or I could have said negative y plus 25, I guess. Maybe I'll do that because standard form. So x equals negative y plus 25. Okay, once you get the variable by itself, you substitute what the variable equals into the other equation. Now this is x, so I'm going to take this and I'm going to substitute it for x in this other equation. So now I have 3 times, but instead of x, I'm going to put negative y plus 25. All right, and then I'll continue with the rest of the equation. Negative 4y is equal to 12. So of course, now we need to solve for the remaining variable y. Let's do the distributive property with the 3. So that's negative 3y plus 75 minus 4y is equal to 12. We've got some like terms here, negative 3y, negative 4y, that's negative 7y plus 75 is equal to 12. Let's subtract 75 from both sides. So that's going to give me negative 7y is equal to negative 63. Time to divide both sides by negative 7. So that's going to give me y equals 9, positive 9. So that is half of my solution. I now have y, but I also need to find the value of x. So that's where the left side comes in. I'll go back to the other equation. I already know that x equals negative y plus 25, but now I know that y is 9. So now that means this will be negative 9 plus 25. So x is equal to 16. Okay, so this is the solution, but we can also write it as an ordered pair, 16 comma 9. So this would be the solution to this system. Now let's review the method known as linear combinations, or also known as elimination method. This method is easy to use when one of the variable coefficients is a multiple of the same variable in the other equation, or if they're the same. So in this case, look at the x's. We have 4x and 3x. Is 4 a multiple of 3? No. So that's not looking good. But look at the y's. We have 10y and we have 2y. Is 10 a multiple of 2? Yes. So that's why this method will work out okay for linear combination, because we have at least one variable where one of the coefficients is a multiple of the other coefficient. So now that we decided that this is a good method to use, step one is to write both equations in standard form. Standard form is like ax plus by equals c, where a, b, and c are the coefficients. The first equation is already in standard form, so we don't have to mess with that. So we can go ahead and just leave this as 4x plus 10y is equal to 24. Now the second equation is not in standard form. The y is on the wrong side. So I will subtract 2y from both sides. So that is going to leave me with 3x now minus 2y is equal to negative 5. Okay, now we noted that the y coefficient is a multiple of the other y coefficient. So that's going to be useful right now, because the next step is to multiply one or sometimes both equations in order to get opposites that will cancel. So focusing on those y's, I see that the other equation has a 10. This has a negative 2. Imagine if I were to multiply this equation by 5. That will turn negative 2 into a negative 10. And then I will have opposites that will cancel. So that's what's happening. Okay, so on my next step, I'm going to keep the 4x plus 10y is equal to 24. All right, I didn't multiply that by anything. But the second equation has now changed. So now I have 15x minus 10y. Don't forget to multiply this constant over here. A lot of students will multiply the first two terms and forget the constant. But this is going to be negative 25. That's very important. So we multiplied so that we would get opposites that cancel. So now the next step is to go ahead and combine these two equations into one. So we are adding. So this is going to give us 19x. All right, these are going to cancel. All right, that's why we made them opposites. And this is going to give us negative 1. So the next step is to go ahead and solve for the surviving variable. So in this case, that's just going to mean dividing both sides by 19. Okay, so that's going to give me x equals negative 1/19. All right, that's a little ugly, but we can handle it. So that's half of the solution. We have now found the value of x. But now we need to go back and find the value of y. So the way we can do that is by picking either one of these two equations, and then we're going to substitute. The second equation looks a little simpler, so I'm going to use it. So I'm going to use 3x minus 3x equals 2y minus 5. But now we know that the value of x is negative 1/19. So let's substitute that in for x. So that's going to give us 3 times negative 1/19 is equal to 2y minus 5. Now this is like 3 over 1, so that's going to give us negative 3 over 19 is equal to 2y minus 5. So now it's time to add 5 to both sides. So now I have negative 3/19 plus 5 is equal to 2y. So I really need to add these together. This is like having 5 over 1, but I need like denominators, so I'm going to multiply both of these by 19. This is pretty ugly. So I've got negative 3/19 plus 95/19 is equal to 2y. So that's going to give me 92/19 is equal to 2y. So now it's time to divide both sides by 2. All right, so I'm dividing by 2. Look, when you divide a fraction by a number, you really can just put that number in the denominator. Okay, now, boom, I've just divided by 2. So, I really would like to reduce this. So, I'm really going to just divide 2 into 92, because I see that that's even. So, 2 goes into itself once, 2 goes into 90 46 times. So this is going to be 46 over 19. So y is equal to 46/19. Okay, what an ugly, ugly number. Okay, so we could write the final answer as negative 1/19, comma, 46/19. Okay, and that is a very ugly example of the elimination method. We reviewed the 3 main methods, which are graphing, the graphing method, and we had substitution, and we had linear combination. And in each case, we talked about when it's easy to do that particular method. So, for example, for problem number 1, I'm going to say substitution. Because I'm noticing that this equation has one variable that is already by itself, and substitution is easy to do when you have at least one variable that doesn't have a number in front of it, a leading coefficient of 1, if you will. Compare that to the other equation. All 4 variables have coefficients, all right, that are not 1. And look at problem number 3. All 4 variables have a coefficient that is not 1. So 2 and 3 wouldn't be good for substitution. Okay, for problem number 2, I'm definitely going to say the elimination method, also known as linear combination. And that's because the equations are already in standard form, and we have opposites that will cancel. So that's great. That's what we need. Even if the y's weren't opposites of each other, it would still be good because the x terms are multiples of each other. All right, 6 is a multiple of 2, and that's really all we need. Now compare that to problem number 3. Even though both equations are in standard form, as we mentioned on problem number 2, this would not be a good problem to do the elimination method, or it wouldn't be the easiest anyway, because none of the coefficients are multiples of each other. 6 is not a multiple of 5. 5 is not a multiple of 2. Now, you could still do it if you multiply both equations, but maybe it wouldn't be the easiest. So I would consider using the graphing method on this one. And that would be because it would be really easy to get y by itself in both of these cases. Look at this first equation. If I subtract 6x from both sides, now I have 2y is equal to negative 6x plus 12. Now if I divide everything by 2, that gives me y equals negative 3x plus 6. All right, negative 3x plus 6. This would be easy to graph. Look at the other equation. If I subtract 5x from both sides, that would give me negative 5y is equal to negative 5x plus 10. Now if I divide everything by negative 5, that's going to give me y equals x, all right, the negative 5's cancel out, minus 2. So it's easy to get both y's by itself, and there are no fractions, all right? We were lucky because when we got y by itself, we had to divide, but in both cases, it divided evenly into the constant. So that would make this a good candidate for graphing. All right, if you said elimination method again, because the equations are already in standard form, that wouldn't be a bad answer either, as long as you can justify it. I sort of already answered this next question. Describe a situation where graphing might be the best method to solve a problem involving a system of equations. Well, if both equations have y by itself, sort of like what I ended up with here, or if you can easily get y by itself without causing fractions, which is what happened on number 3. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.